All right, everyone. This is going to be a really quick animation lecture, mostly on Jupyter Notebooks, just because it's easier for what I'm about to show you. But yeah, we're going to talk about some animation, for those of you who are interested, or for those of you who just kind of want to learn, or for those of you who are trying to do something like this for your final project. Yeah, so let's jump right in. So when you think about an animation, you probably think about old cartoons, and that is actually a really great place to start. So I'm going to show you this really quick. I want you to be thinking about what an animation actually is. So what makes it an actual animation? Like what are the component parts? And I encourage you to show you this first. So, as you can see from the very beginning, you see pages flipping, and you see the illusion of movement. And this feels like a really kind of a less useful or a very mundane point to emphasize, but it's really important for when you're thinking about what animation is. So I'm going to encourage you right now to think about what tools that you have already to work through animation and what you are missing. So go ahead and pause now if you would like. Otherwise, I will just show you. So, animation, as we saw, is very much um, you're stacking together figures, which we know what figures are. They're plots, they're pictures, they're things that we've done in the past, quite a bit, actually. Um, and they're things that you will continue to be more and more familiar with. And the way I want you to think about animations and simulations going forward into your career is as showing a progression of figures as they continue to move, or showing a progression of figures in a way that's very easy to digest. We are very used to seeing videos. They turn into MP4 files, or .mov files, or whatever type of video files that you are using. So let's jump right into it. Let's animate an interesting function. So let's first start by importing NumPy, because we always need NumPy as NP, not P. We'll need matplotlib as per usual. We're going to also, this is the new one, from matplotlib import animation, and from matplotlib dot animation import FFMpeg writer. The capitals, or it is case sensitive, so be very aware of where you are putting capital letters. If you get an error, I'd highly recommend reinstalling matplotlib with pip install, seeing if that works. And if not, feel free to contact me. Or if you want, go to datahub.berkeley.edu. You definitely have a you definitely have an account. Everyone does. And everything is installed there. But I don't think you'll need it. I'm pretty sure that since y'all have the most updated version of Python, it should be there. Okay, so let's choose a function to animate. I don't know, I'm feeling kind of like two-dimensional animation just for funsies. They're very interesting, very fun to do. And gives you a lot of practice. So let's do it. Let's actually, so if you go up here, you can call it a markdown. Let's call it a cool function, because that's what we're doing. We're plotting a cool function. And what you're gonna do, or what I'm gonna do is, I actually have this prepared. So if you're interested, take a look at this cool function. There's the way to put it into into Jupyter Notebooks. Don't worry about it too much though. So let's start by plotting it just to make sure we know how it is. So as we all know, we do the np.mesh grid to create a grid of values that you'll be using, and I like linspace, so we're going to do that. Times np.pi, since we have a sign in there, we're going to do pi. We're going to do values of, we're going to do multiples of pi. Nice, quick, relatively easy. Then we will do np.linspace. np.pi, comma 10 or 1000. Great. So now we have an XY grid that has 1,000 points on each side that goes from 0 to 2 pi on each axis. So now let's define our function. We're going to call it f because I'm not particularly creative, which is fine. And our only two arguments are x and y. If you would like, please take a second, see if you can code this up by yourself. Go ahead and pause the video if you would like. At any point during this video, feel free to do so. Yeah, so we're going to do just gonna say return np.sign of 10 times x squared plus y squared. 10 times x squared plus y squared all over 10. Great. Now we got our function. Should call it function? It makes more sense in my head, and that way I can do this. Function of x equals x and y equals, Jesus, equals y. Okay, great. So now we've got f. Make sure we have it. Yes, we do. Cool. Now all we need is to plot it. So remember, we do plt.figure always. I like to set the fig size equal to 8. I think that makes it big enough. We'll do plt.show. God, okay, I have to plot something to show you the figure. That's fun. Okay, so we'll do plt.imshow viridis is the default. I don't like viridis very much. It works, but I like Inferno. We can set it like this. Inferno. So we plot it. Oh, what's our... Oh, C map, not color map. There it is. Cool. She's cute. We love her. That's a very interesting color map. It's a very interesting plot. Let's also do plt.colorbar so we can see what our values are. You can see it automatically does this. There is a way to shrink it to match the figure size, which I like to do. It's this shrink equals 0.5 I don't know, 8 generally works. Yeah, see there, it lines up a lot better now. And it'll make the animation look a lot better. So now that we have plotted this, if you're a little unsure about this plot, please take a second and make sure you know what's going on here. Yeah, and then let's move on. Let's start the animation itself. Let's call this Markdown because we like being organized. And we'll say, okay, starting animation. Cool. I just want to put that there so I'm not starting at the bottom of the page. It's weird for me. Cool. So let's do this. There's a lot of things you kind of just have to memorize, unfortunately. And one of those things is if we are saving it as an MP4, or that's not important quite yet. Okay. The first thing we have to do is initialize the writer. So the writer is the thing that sticks all those pages in the flipbook together. It's what makes the video an actual video. Super interesting. I don't understand how it works very well. I think it just adds it as frames, but I couldn't explain how it does it. So yeah, feel free to look into that if you're interested. First step is to make metadata. You don't necessarily need to do this, but you can. It's good practice. It's very well written out. Yeah, so let's do this. We're initializing a dictionary. We're calling title, God, equals, I don't know, I'm gonna call it cool function. And it needs an artist. It needs us to tell it what artist to know. So artist equals matplotlib. Cool. We got some metadata. All the metadata means is that it's data on what you are doing. It kind of describes what's going on, and a lot of file formats actually require it. Cool. So now let's create the actual writer, but first we're gonna add some documentation because we are good coders. Making metadata. We're gonna call it making descriptive metadata. Okay. Now let's make the writer. We call it writer. You don't have to do that. It's just a variable. Do whatever you want. Writer is a good choice. It's very descriptive, very easy to follow. I recommend it, but you don't have to. So, we are going to initialize a object, and it's called FFmpeg writer, and we imported it here, so it won't throw us any awful things. It won't throw us any stupid errors because we know. Sorry about that. Because it knows what it is. So that's good. Wow, I am still in spring break mode. Sorry, guys. So this is frames per second. And we're just gonna call it 50. You can change that, speeds up or it changes the rate at which your frames last. We're just gonna call it 50. It's a good amount of frames per second. Tried and true. These are just values that I have learned are good ones or found out are good numbers. I played around with a lot, so I recommend you do so. So metadata, I'm just going to call it metadata. Okay, I guess the metadata is necessary because FFmpeg writer takes it as a argument, but let's see, FFmpeg writer arguments. Okay, cool, right there, love that. Okay, yeah, it looks like you need it. Okay, yeah, it looks like you need it. It looks like it won't let you do it if you don't have it. Although since the default is none, maybe that's a lie. So you probably don't need to have it actually. But it is good practice because it tells you what you're doing. And it tells other people what you're doing. So this is byte rate. This is something I've been told is an important argument. And I've been told this is a good number for it. 200,000. Let's see. Byte rate. It's kilobits per second. Oh, bit rate. It's the rate of bits that you are actually transmitting, which is okay. Cool. Bit rate, not byte rate. Okay, next. So that's we've initialized the writer. That's a good thing, and no errors, so that's good. If you get an error, Google it. So let's start with creating our figure. So we've kind of lied a little bit about plotting in the past. Like this sort of thing works. Obviously it works. If it didn't work, it wouldn't work. That was what a statement I just made. Matplotlib is so this type of coding is called functional coding, and that just means you're doing things, whereas matplotlib is designed as an object-oriented like programming package. This figure is an object in Python, and objects mean something. We have an object-oriented programming lecture coming up, so stay tuned for that. But for now, all you really need to know is that the syntax is a little different. So let's get going. So we're going to create this plt dot subplots where fig size equals 5. These are numbers and things that I have found in the past. So this is why I am doing it the way I am doing it. Cool. We're also going to initialize some the number of iterations through our how many frames basically we're looking at. So each time we're actually going to end up adding 1 to all of the x values and all of the y values and seeing how it evolves. So we're going to define num iterations to be equal to 20. Obviously, the more iterations, the longer this will take. It's kind of a lengthy process. Not necessarily the coding portion, but the actual generation of the movie file. So now we are going to open up the writer, and we're going to start using it to save figures to it. And we're going to call like with writer.saving. Remember we defined writer up here. With writer.saving fig, and we defined that up here. It is a object you get when you call plt.subplots. So we're just telling it what figure to save. And we're going to name the file. I'm going to name it cool function dot mp4. And we're going to call dpi equal to 200. Now, I always forget what DPI stands for, so let's find it. It's writer.saving. Okay. Saving. Come on. FFMpeg writer.saving. What is DPI? Got it. Dots per inch. Wow, that's a pixel resolution thing. I did know that actually. Cool. How many pixels are you giving it? Or how many dots are you giving it per inch? We're giving it 200. It works. And we are going to do a colon. When you hit enter, it's going to automatically give you a tab right there. It's really nice. Automatic white space is great, as you guys have found. It's really painful to have to add your own white space, but Jupyter does it for you. I think VS Code does too. Next, we are going to iterate through the number of iterations that we want to update our figure, and then which we will then append to the file, the MP4 file. So we're going to say for I in range 0, comma, num iterations, which we are opening inside of this writer.saving block, which just means that we have opened the writer and we are going to be saving things to it. So right now the computer knows that we're opening the writer to make an animation, basically. Then if you hit enter, first thing we're going to do is ax.clear. So what that does is it clears out your figure and it says, okay, it basically says now we're going to plot something else onto this figure, which is useful because we're going to be plotting at 20 frames. Next, we're going to say x plus equals 1 and y plus equals 1. So every time we go through this iteration, x will be plus, or x will be 1 more and y's will be 1 more. And then let's call f equals function of x comma y. X equals x, y equals y. Cool, great, lovely. Next, we've got ax.imshow of f. Great. CMap equals, let's do turbo instead. That one's fun. Let's do ax dot, I don't know, can I do color bar on here? I don't really want to find out. Okay. This is the magic bit, and the magic bit is plt.draw. This tells the computer to draw the figure that you see on that you've created with ax.imshow onto, or you sorry, it tells the computer to draw the plot that you've created with this line onto this figure. And then we're going to pause. This basically says, okay, how long am I going to pause for? And I'm saying I'm going to pause for 0.1 seconds. And then writer.grabFrame is probably one of the most important parts of this whole thing. It tells the computer, okay, here's a frame. Now you can append it to our movie file. Great. Let's move on now. Save the current frame to the MP4 file. Cool. Now, we should be able to just hit enter and let her rip. Oh, never mind. No such directory as FFmpeg. Cool. File not found, error. Cool. Awesome. Love that. Okay. Yeah. So, I just spent a little bit of time troubleshooting the FFmpeg issue. All you need to do, if you are getting the error that I showed earlier, is to type in brew install FFmpeg. So now let's make sure that's correct. And say fman FFmpeg. There it is. Okay, and the way to get out of this is with a Q. Cool. Great. So that should work now. I say that every time. Let's again refresh kernel, restart. Okay. You can see kernel's ready. Great. Enter, enter. Moment of truth, y'all. There she is. Look at her. All right, and you can see she's still running. That's because she takes a second. So you should see all of these things. That's good. This is normal. This is good. So now if you go back to where you were, we have cool function.mp4. Look at that. Moves so fast. Yeah, cool. Let's see if we can get it with our we can increase the number of iterations to 200. You'll see quite a few, it'll take quite a bit longer. And you're just gonna keep generating these little guys. Just so fun. I'm actually gonna interrupt this because I don't want to wait that long. And the way you do that is by clicking the stop button. Okay, cool. It stopped running. Great. Let's refresh this. Cool. Cool function. Should go for a lot longer. Oh, that's so fun. Oh, yeah, there it is. So, okay, that's super interesting. And I love that personally. Reasonable people can disagree. So if you disagree, that's fine. But I think that's super cool. And it works for everything. You can just replace the function with whatever you would like. And update things as they go. So thank you so much for bearing with me. And I hope you all had a great spring break.